Good morning. This is Dr. Randhi Reddy, Professor of Mathematics, Department of Freshman Engineering, St. Martin's Engineering College. So today we are going to discuss the concept of spherical polar coordinates and the relationship between Cartesian coordinates and the spherical polar coordinates. So for this, first we'll discuss what is the spherical polar coordinates and then the relationship between Cartesian coordinates and the spherical polar coordinates. First, spherical polar coordinates. In general, there is a different types of coordinate systems. If it is a Cartesian coordinate system, the coordinates are x, y, z, which is under the coordinate system of Cartesian. Cartesian coordinate system, this we are already discussed. If it is a two-dimensional space, the Cartesian coordinate system, which is called it as the polar coordinate system. If it is a cylindrical coordinate system, what is the coordinates are r, theta and z, which is called it as cylindrical coordinate system. Now our concept of spherical polar coordinate system. The spherical polar coordinate system, the coordinates are r, theta and phi. This is spherical polar coordinate system. So this we are going to discuss today. What is spherical polar coordinates? The coordinates of r, theta and phi. Then we can identify the relationship between x, y, z, r, theta and phi. So before that, what is the use of the spherical polar coordinate system? The applications we'll discuss at the end. But before that, the simple concept of the use of the spherical polar coordinate system is, in general, in a three-dimensional space, how to identify the volume or areas. Usually we can identify the areas or volumes by using the triple integral, but by converting the Cartesian to polar coordinate system, spherical polar coordinate system, it is easy to evaluate by using the concept of spherical polar. So that is the general usage or the big usage of the spherical polar. And before that, before we identify the relationship between Cartesian and the spherical, what is r, theta and phi? We are defining the coordinates r in the spherical polar is r, theta and phi. What is r? What is r? Here r is called it as radial distance, and theta is called zenith angle, and pi is called azimuthal angle. So this is in general what is r, theta and pi. So now our target is to identify the relationship between Cartesian and spherical polar coordinates. So now our target is to identify the relationship between Cartesian coordinates and spherical polar coordinates. It means we are already discussed what is the coordinates of the Cartesian is x, y, z. What is the coordinates of spherical polar? R, theta and phi. It means now we identify the relation between r, theta, pi to x, y, z to r, theta and pi. So for this purpose, now I will consider one three-dimensional space. This is x, y, z with the Cartesian coordinates of three-dimensional space x, y, z. Now I will consider one point P. Now I will consider one point P. Here the point P, the coordinates in terms of Cartesian is x, y, z. Now, but here I can consider in terms of spherical coordinates, the coordinates are r, theta and phi. Now we are considered as of now one point P. That point level, what is the coordinates r, theta and phi. Here what is the Cartesian coordinates x, y, z. Now here the intersects point of x, y, z is called it as the origin. Now from origin, now I can consider one line from O to P, from O to P, O to P. That O to P distance is called as, it is a radial distance and it is denoted as r. It means as of now OP is equals to radial distance, OP is equals to radial distance r. Now this OP line segment makes an angle theta. Now what is theta? R is what? R is distance from O to P, which is called it as a radial distance. Now what is theta? Before theta, I can consider one perpendicular line from P to Z axis. It will intersect at a point A with an angle theta. Now what is theta is? What is theta? The line segment OP makes an angle on Z axis is called theta. What is theta? The OP line makes an angle on Z axis. It is a positive Z axis at a point A, which is called it as the theta. So now, we are considered one perpendicular line. It intersects at a point A and theta is the angle. Now next level, I can consider P is the point in a three-dimensional space. Now I can consider its projection on ZY plane. It means its projection, the point is Q. What is Q? Q is the point of projection of P on ZY plane. Now I can consider one perpendicular line. Already we considered one perpendicular line at a point P. At a point Q, I can consider the two perpendicular points. One is on x-axis and another one is y-axis. That is, this is one perpendicular line. It means here the angle is 90. For understanding purpose, here also I am mentioning the angle is 90. Here the point is denoted as some B, and another perpendicular line on y-axis this is at a point C, this is also for identification, this is also 90. Now I can consider a line from O to projection point. O to projection point. Here we can consider one more angle phi. Now what I did, I considered one projection point from P to Q. From O to Q, I make one line which makes the angle theta from x-axis, and I considered the two perpendicular lines. One is on x-axis and another one is y-axis. Now what is phi? As of now we have discussed what is r, what is theta. Now what is phi? Phi is what? The line segment, the line segment OQ, this line segment OQ makes an angle on x-axis, is called phi. Now this is the diagram from the origin. This is the distance OPR from the definition of the Cartesian coordinates. What is the distance from O to A? This is in general definition of the Cartesian coordinates. It is x. And what is the distance from O to B? It is z. It is x. And what is this? Y. It means OP is equals to R and OA is equals to Z. As of now, what we are identified, and OB is equals to X and OC is equals to Y. Right? Now, so what is our target is? To identify the relationship between X, Y, Z and r, theta and phi and vice versa. So for this purpose, from this diagram, I can identify the relationship. So from this diagram I can identify the relation now. From this diagram I can consider the right angle triangle. So right angle triangle OAP. So for understanding purpose, I am rearranging the triangle. This is the point O. Here the angle is theta, and here the point is A, and here the point is P. You know, from the right angle triangle, this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So from this, you know already the formula of cos theta. From this right angle triangle, I am identifying cos theta. So what is cos theta? Adjacent side by hypotenuse. Yes. What is adjacent side? OA by hypotenuse is OP. What is OA? We are already identified. It is Z. So cos theta is equals to Z by OP is, you know already, R. So from this, Z is equals to R cos theta. It means Z, we are identified a relation R cos theta. The next one is, from this diagram, I can consider another triangle. The right angle triangle is triangle OPQ. So before consider this triangle, here the angle is theta, so that automatically here is also the angle is theta. Now I can rearrange that OPQ triangle. I can consider the right angle is at Q and the angle is at P, and this is O. At a point P, the angle is theta. Now this is the right angle triangle. So from this, previously I can consider the cos theta. Now here I can consider sin theta. So what is sin theta? opposite side, this is base, and this is hypotenuse. So it means opposite side is nothing but OQ and hypotenuse is OP. It means OQ is equals to OP, you know already, R. It means R sin theta. It means OQ is equals to R sin theta. Now, so now I can consider another a triangle, So that is OBQ, the right angle triangle OBQ. So what is the right angle triangle? I can rearrange the triangle. Okay, it makes an angle pi at a point O and the right angle at a point B, and this is the point of Q. So from this is the opposite side, and this is the base or adjacent side, and this is the hypotenuse. From this again I am identified cos theta, cos pi. Now the angle is pi, so that cos pi. What is cos pi? Adjacent side by the hypotenuse. It means what is adjacent side? OB by OQ, which implies what is OB is equals to OQ cos pi. OB you know already X, OQ you know already R sin theta cos pi. It means what is the X relation now in terms of R theta and pi? R sin theta cos pi. From the same diagram, I can calculate sin pi. What is sin pi? Opposite side by the hypotenuse. What is the opposite side? QB or BQ by hypotenuse is OQ. It means what is BQ is OQ is R sin theta sin pi. Now you observe this diagram. So from this diagram, these are the two perpendicular lines from a point Q to B and Q to C. These two are perpendicular, so that the distance from O to C, is Y is equals to the distance from B to Q. And the distance from O to B is also equals to distance from C to Q. By using that logic, what is the BQ distance now? Y is equals to R sin theta sin pi. So that is why R sin theta sin pi. Now we got the relationship between X in terms of R theta and pi, Y and Z. Now what is the relationship between Cartesian coordinates? Cartesian coordinates and the spherical coordinates is X R sin theta cos pi, Y R sin theta sin pi, Z R cos theta. So this is from X, Y, Z to R theta and pi. In a similar way, how to write R theta and pi in terms of X, Y, Z? So for that, so first what I am doing is I am squaring and adding of 1, 2, 3. Then what you will get is R square is equals to X square plus Y square plus Z square. Then R is equals to under root of X square plus Y square plus Z square. This is one relation number 4. Now from Z, from 3, what is Z? R cos theta. From this, what do you want? Cos theta is equals to Z by R and theta is equals to cos inverse of Z by R, or you know X square plus Y square plus Z square. This is equation number 5. Now we got the relation R in terms of X, Y, Z, theta in terms of X, Y, Z. Now from X and Y, from X and y. What is phi is equals to tan inverse of y by x. If you rewrite the 1 and 2, we got the relationship between phi and y and x. Now we got the both the relations, Cartesian in terms of spherical and spherical in terms of Cartesian, right? So now, so this is the relationship between Cartesian coordinate system xyz and the spherical polar coordinate system r, theta and phi. So this is the general relation. Now we'll discuss one example. So now we'll discuss one example. Now we'll see one example how it will convert if we know xyz, how to convert r, theta and pi. Okay. So we discussed already the relation. So now in this example, we are given the values of 21, 28, 32 is the xyz. Now how to convert? You know already the formulas r, theta and pi. Simply by substituting xyz values, then we'll get the values of r, theta and pi. This is how we'll convert. If you know the x, y, z, how to convert r, theta and phi. Now this I will explain by using graphically how we'll take the theta angle, how we'll take the pi angle. This I will show you by using a video. You see this video. So this is the three-dimensional space with r, theta and pi. Theta makes an angle between 0 to 180 and pi makes an angle between 0 to 360. By using this, we can identify the volume or area of any particular part in a three-dimensional space. This will show by using the different formulas, we'll get the volume or areas. This is one application about the spherical coordinates. One more application we'll see. This application is if you know x, y, z, how it will convert r, theta, pi graphically. And by fixing r value, vary with the theta and pi, by fixing theta value, by varying r and phi, by fixing pi value, vary with the r and theta, we'll get the different shapes, which is called it as plane or cone or sphere. We'll get this beautiness by using calculating different by fixing with r constant or theta constant or pi constant. You observe this. So how theta fixed and here they considered as rho, it means r pi is vary. If r pi is vary, then plane is generated. How the plane is generating? If pi is fixed and r and theta is vary, then cone will generate. How the cone is generating? If r is fixed and the angles are vary, then sphere will generate. The sphere will generate. So once the plane generate, cone generate or sphere generate, out then the next target is how to identify its volumes or areas using spherical coordinates are the easy. So this is in general the geometrical representation. Now we are already discussed one example. Now what is its application? So one application we'll discuss here. So one application we'll discuss. This video, the graphical representation we already discussed. Now the one special application, you see this is the robot configuration. If it is a Cartesian, it looks like this. If it is a cylindrical, it's look like this. If it is a spherical, it's look like this. What is the beautiness of the, if you use the concept of the spherical coordinates, the complexity is very simple and the joints are short, but it moves in a very good direction and compatibly with other robot and machines in common workplace. It means with use of the spherical, the usage is more and it is more flexible rather than the general form of Cartesian and the cylindrical. In the same way, one more is also there in the form of robo. You observe this spherical coordinate system is fully guide the rope in a three-dimensional space. So this is one application we have discussed here. So this is the today's class. First we are identified the relationship between Cartesian, the relationship between Cartesian coordinates and the spherical coordinates. Next we discussed one example how it will convert from Cartesian to spherical and how it will deploy in terms of graphically graphically, and then last what is one application. So can we remind once again what is the relation, what is our final goal of a relation we identified? Our target is to identify the relationship between x, y, z to r, theta and phi. From this we are identified first what z is equals to r cos theta, then x is equals to r sin theta cos phi, and y is equals to r sin theta sin pi. This is one relation. And the second relation we are identified what? R x y z in terms of r theta and pi. R theta and pi is also we are identified. R is equals to under root of x square plus y square plus z square, and theta is equals to cos inverse of z by under root of x square plus y square plus z square, and pi is equals to tan inverse of y by x. So this is today's class, the relationship between Cartesian coordinates and the spherical coordinates in terms of Cartesian coordinates. So thank you very much.